Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I just appreciate you watching. So I want to make things really clear as we're getting started here today, because it might be just a little bit confusing with where we're at the next few weeks, right? Today, Module 6 is due, and we're starting material for Module 7, because we always start our next module on the day when assignments for the previous module are due. So Module 6, string manipulation, due today. And we're starting to cover Module 7 topic information in the live class today. Module 7 is a 2-week module. So we will have this week's class on lists and next week's class on lists. We might just have them just a little bit shorter. And I probably will spend more time sitting and writing code next week So it's 2 weeks from today when Module 7 is due. So Module 6 due today. Module 7 due 2 weeks from today. And that's basically that. There are some big concepts when it comes to talking about lists that it would take us a couple weeks to kind of go through all the big topics that I want to talk about with them. Right? In other programming languages, you might hear the term array. Array is just another term for what we're dealing with here. Lists. Array is the more common term for lists. When we are dealing with lists, as we are here, list is a Python specific term. In other programming languages, we would call them arrays. So as I'm talking about lists, I'm going to do my best to call them lists within the context of Python. But if I start calling them arrays, you know why. That's another name for them. And so one of the things that we want to do before we start talking about lists is we want to think back and review for a minute. Right? Several weeks ago, now it's been, probably nearly 2 months ago now, right? How time flies. We started talking about the concept of a variable. And we said that a variable is basically just a container. We put a label on that container. And then in that container, we can put data into that container. And we can take data out of that container. And so having a good understanding of a variable is going to give us a better understanding of lists or arrays as we're starting to talk about them. Right? Because what we see in a list is a very similar structure. We're just expanding it out a little bit. Right? For example, if we say that a variable is a container with a label on it, for our lists, we can say that a list is a big container with a label on it. And we can bring things into it and take things out of it. But in this case, what makes a list special is that we're not just talking about data values like we would with a singular variable, but we're talking about other containers. And each of these containers have their own little label on them. And in each of these little containers, I can put data in and take data out. Right? So we're getting a very similar structure that we would get to that of our variable. But in this case, we kind of have some nested variables. And we kind of have these variables that are nested together for a certain purpose. And so if we were to do a more formal definition of a list, might look something like this. Right? We might say that a list is a sequential collection of values. And it's one of the things in programming that we call a data structure. There are certain elements in programming that that are termed data structures. A list is one of them. A list/array is one of them. A linked list is another one. A dictionary. A two-dimensional array. There are several different things that we call data structures, and they give us the ability to structure our data, right? Matrix is another example of a data structure. It gives us the ability to structure our data. And so each value has a location or an index, right? And this is why we talk about string manipulation before we start talking about lists, right? Because the same things that we were talking about in the live class last week, when it comes to addressing the individual characters in a string, we can use that same understanding to wrap our heads around addressing elements in an array or in a list. Right? For example, if I have a list, this list will have several values in it. And so one of the things about a list is that a list is mutable. We can add things to a list. We can take things out of a list. We can change things in a list. So we'd have a tough time referring to the items in the list by their value, which is why they need to be indexed. And so similarly to last week when we were talking about indexing a string, we index items that are a part of a list in the same way, where we start counting at 0, and we count up from there as we go left to right. Or if we wanted to go right to left, we can count down with negative values. And it's this addressing that allows us to access specific elements that are within a list. So we can kind of think about it like houses on a street, right? You know, we used that analogy last week. It's even better this week, right? The street has a name. That name's going to be the name of your list. Every house on the street has a numeric address, a house number. And so that house number is going to be like the index location. And so if you take the house number and the name of the street, you know exactly where the house is, and you can access it, and you can get the data from it, or whatever, right? So each value has a location, which is an index, and our indices range from 0 to n-1, as we said there, where n is the length of the list, right? We mentioned that last week when we were talking about length of strings, where the length of the string is, you know, how many letters are in the string. The length of our list is how many items are in our list. But since we start counting at 0 instead of 1, the last item won't be the length of the, in the value of the length of the list. It'll be in the value of the length of the list minus 1 because of where we start counting. And then we go from -1 to -n, or the negative length of the list, in the opposite direction. In Python, which is a stark difference, opposed to other programming languages, lists are heterogeneous. Meaning that I can have many different types of data in a particular list. All right, so I believe we have an example of this on the next slide here when we're talking about list syntax. So I will go there. Yes, indeed. So when we're talking about the list syntax, this is talking about how we would write a list in our program. And so here, we can see in the first bullet point here, this is what I mean about a heterogeneous list, right? We have a list here. We've given it a value. We've given it a name of my list. right? And inside of these square brackets here, we have 3 different pieces of data. Each piece of data separated by a comma. We can see we have the number 3, right? That is the integer value of 3. The character A in a string, and the Boolean true, right? So we have an integer, a string, and a Boolean, all 3 of these different data types in a singular list in Python. That is perfectly acceptable. That works just fine. In other programming languages, there's a high degree of likelihood that that is not built in, right? That all of your data in your list or array has to be the exact same data type in other programming languages. In Python, we could switch it up a little bit, although I will say that I've not really found a good use case to have a heterogeneous list like this. The best I can think of is when we can kind of use one as a little pseudo database, right? Because we can put any data type inside of a list, including another list. So if we have a list of lists, which we call two-dimensional lists or matrices, if we have a list of lists, then we can kind of use it as like a pseudo database to be able to pull different pieces of data for different things. But with where we're at right now, that's neither here nor there. In the next module, I believe, we get more interested in some different things like that. So we know that we can put any type of data in a list, including another list. We can even initialize with an empty list, where you just have an empty pair of square brackets. And this is useful a lot, right? Like if I wanted to create a program that's going to temporarily store pieces of data that my user is entering, for example, then I might want to start with an empty list and then add to that list as my user is entering more and more data into the program. So, for example, we can use a loop to allow our user to put in multiple inputs. We can take those multiple inputs and store them temporarily in a list, and then we can use that list to do different computations. So let's go over to a replit right now, and let's go ahead and try out making a list and just playing with it a little bit and see what we get there. Let's head over to a replit. And let's go ahead and start out with our shebang. Hash bang. USR, BIN, ENV, Python 3. And let's create a function that's just going to allow us to play with some lists here. So we'll create a function. We'll call it list test. And no parameters necessary for this particular function. So we'll go ahead and deal with it as it is. So let us just create a simple list. We will call this list, we'll call it list 1. Right, we'll set that equal to a set of square brackets. So right now this is valid code, right? If I went to print list 1 and I called this function, let's add our main gate here, and call list test, we would actually get a result print out, right? This is valid code. We shouldn't expect an error here. And we see that, right? We just get 2 empty square brackets here. So let's put some values in here. Let's just put a sequence of numbers. Let's try 2, 7, 4, 12, and 5. Right, so now we just have a sequence of numbers in our list here that we can work with. And so if we run this now and see the results, we can see the output looks the same basically as the input, right? It's wrapped in square brackets. Now, in Python, and really in any programming language, as we've kind of mentioned here, a list is its own data type, right? So if I run the type function on this list to see what kind of data type it is, even though it is full of integers, we get a we get an interesting output here, right? It tells us it's a part of a list class, right? So it is a list object. It is a data structure that contains these different elements. So we can do certain things with our lists without having to recompose everything. We call this a list comprehension, which we'll talk about in just a little bit. But for the most part, if we want to do something with the data values in our list, we need to identify those data values directly, or we need to do some manipulation with the values that we're working with. Right, so for example, let's say I want to access this number 4 here in our list. And I know I want to use this number 4 here directly for some kind of calculation, right? I've put it in this function to do, or put it in this list to do something with it like that. And so I know that if I'm going to address this 4 specifically, this is index location 0, this is index location 1, this is index location 2. Right, so if I refer to list, and then in square brackets beside the term list here, or this should be list 1, rather, because that's the name of our list, and in square brackets beside the name of our list there, I put 2. That's like saying, 301 Main Street, right? That's saying go to 301 Main Street and look at that house that's there, right? When we print out just list, we see all the houses that are on the street. When we see list 1 square brackets 2, here we are specifically looking at the item in the second index location. Again, that's 0, 1, 2, which is going to be that 4. And we get that output there. And something to notice about that output is there are no square brackets around that output. Right? There are no quotes around that output. So it is just the integer data value here. By addressing it directly, we have, in essence, kind of removed it from the list so that we can focus on it. Right? It's still a part of the list. We haven't actually taken it out of the list yet. We could do something of that nature, which we'll probably talk about next week. But for right now, we are focusing in on this one element of the list. And we can basically treat these values just like we would anything else, right? And we could say like, oh, let's do list 2 plus list 3, right? So that would be the item in the second index location of our list here, which would be the 4, plus the item in the third index location here, which would be the 12. And if we evaluate that code, oops, I forgot to put list 1 instead of, we get 16. Right, because that's 4 plus 12. Right, we're able to access these different elements in our list, and from there we can do whatever we want, right? Like this is where I get to that sort of thing that I was talking about earlier, where the list is kind of like a container full of variables. Right, because another one of the things that I can do here is I can change the value here by addressing the index location directly, right? The index location of a particular element in a list is mutable, and the list itself is mutable, meaning that we can change it. We can add things, we can remove things, we can change values, right? And so I can perform a reassignment on that one particular part of the structure. And so if I said list 1, index location 2, right, addressing that 4 again, and change it to something like 30, right, once it hits that part of my code here, once my interpreter hits line 5, it takes that value for list 1 at index location 2, and it reassigns it this new value. So if we run this code now, since this equation is below the reassignment, right? Remember, order of operations, top to bottom, left to right. So where that print statement is critical to what we get on an output here. But we should expect a much larger number when we run the function this time, because we have reassigned the value that we have in list 1 index location 2. Right there, right? We get 42. 42. Because it's mutable, it's changeable. And that's where, the real power of the list here starts to come in. Right, another thing that I can do, for example, is I can take this list and I can run it through and iterate it and address each individual part. So for example, maybe I have an I variable here, I of 0, or we could use our enhanced for loop like we talked about last week for I in list 1. We can just check each number, each item in list 1, and we can say if I greater than or equal to 5, then we can add it to some other value. Let's create an output value here and set it equal to 0. And now we can say, any value that it's in our list that's greater than or equal to 5. Let's add it to the value of output. So output plus equals I. And so now if we print out the result here of output, we are left with 54. 7 plus 30 plus 12 plus 5. Now, if we change that slightly and we said I greater than 5, right, then the 5 at the end of our list here no longer impacts this conditional statement. So we should actually expect for this to be 49 as a result, because it'll leave that one out. And we get 49. Easy peasy, right? Just getting started with some list basics here today. We'll get into some more advanced stuff a little bit later on. But as we can kind of see here, our lists are powerful, right? And we can do a lot of stuff with them. We can add data to them. We can change data from them. We can make things happen. Right? And so if we head back over to our slide deck really quickly, we can have in a visual sense some of the things that we just talked about. So we can say, we can just have on a commitment to the record here that lists are mutable. The elements in the list can be changed, and the list can be changed itself. Right? Meaning that we can add to the list, we can take away from the list, we can change the individual elements inside the list. We just saw that happen, right? We also just saw individual elements being changed the same way any variable can be changed, by doing reassignment. We can also use variables as the index location, right? Because as we've kind of said before, a variable is just the data that's inside of it at any given time. Right? So in the example that we're given here, we're given a heterogeneous list with the values 1, 9, A, 4, and 7. We are creating a variable here called M. And that variable is given the value of 3. And then we're looking at my list at index location M, which in this case is index location 3. And so if we look at that and we go 0, 1, 2, 3, then we know the item in the third index location here is this 4. And so the third bullet point there, the my list at index location M, is addressing what prior to that line of code would be a 4. But this line of code reassigns that at a 99. So imagine just kind of coming in here, crossing that out, and writing a 99 in its place. And then the next line after that looks at M plus 1. So the value of M is still 3. So this would be 3 plus 1, which would be the index location 4, which would be the next one in the list. And we're doing a reassignment of that value there as well. Right? We just saw some examples of that. Now we can also use the len function, just like we did with our string, to get the length of our list. So it's going to count the number of elements in the list instead of counting the number of characters in a particular string, which gives us some added value, right? So if we look at our replit again, and we look at the list that we've created here, we can kind of look at what we've done here with this for loop, and we can kind of rewrite that in a particular way by taking advantage of that len function. All right, so first if we just print out the value of len list 1, then we expect to get the length of list 1, which should be 1, 2, 3, 4, 5. Right? We should expect a 5 on my output here, which is exactly what we get. And so now let's use that and let's deal with this index location so we can kind of do this same thing that we are doing in this enhanced for loop here, but doing it in, let's say, a while loop while also taking advantage of the length of list 1 here. So let's create an I variable now, and we'll set that equal to 0. And we can write a while loop here that'll be while I is less than the length of list 1. Right, so we know the length of list 1 is currently 5, but the reason why we would want to do it this way instead of just saying I is less than 5 is because the size of that list can change, right? We've said our lists are mutable, so the size of the list can change. It can grow, it can shrink. So if it shrunk down and we're trying to address a certain element, that element might not exist anymore. If it grew bigger, the element that we're trying to address might be in a completely different location. But if we're going for the last item and we want to traverse the entire length of the list, using the len function on our list will get us the exact length of the list every single time without us having to change our code, which is why this is beneficial. Right? And so in this case, we'll just start out by saying print I. And we will comment this other line here out. Right, so what we should expect now is go through, print the object in at I. Now this I here is just a number, right? Like right now it's 0. So while I is less than the length of list 1, print I. There are two things that we're not doing yet. We're not putting I in the square brackets to act as an index location for list 1, and we're not incrementing the value of I yet. So if we just tried to run this as is, we'd get zeros forever until our program errored out. So what we want to do here is we want to make sure we do two things. One, we want to make sure that we actually increment the value of I plus equals 1, so that when it reloops, it takes that step toward the breakpoint, right? So now we get to count 0, 1, 2, 3, 4, which is 0, 1, 2, 3, 4. If our list grew by 1 or 2 or 3, then we don't have to redo that code since we just used the len function. It's just going to update automatically. And so now if we add list 1 and put the I in square brackets, and just to kind of, let's put the index location beside it, just to kind of make sense. So I'll print I and then the number at list 1. So we can see them kind of line up here. We'll be able to see the items at the different index locations and the values at the different index locations. So we see at the 0 index location, we have the number 2. At 1, we have 7. At 2, we have 30. At 3, we have 12. At 4, we have 5. At 5, we have 13. At 6, we have 4. At 7, we have 7. Right, and of course, the item at 2 is 30, because, reminder, we did that. Now, if we wanted to, again, we could also put in here that same conditional statement like we did there. But in this case, we'd have to address it with the value of the list. So it would be if list 1, index location I, is greater than 5, we will add it to the value of output. Output plus equals list 1 at the index location of I. Right, and so in this case, we added 13 and we added 7. So we added another 20 to it. So now instead of 49, this should be 69. If we printed out the value of output. So let's add a print output. And that's exactly what we end up with. Right, we still left this print statement in our code. For testing purposes, if I was writing this as real code, if I didn't want that in there anymore, I might want to come here and just kind of comment it out. That way I could have that there later in case I needed to do testing again, but it's also not going to show up on my output. Lots of fun stuff. There. So just a few more. I want to do just a couple more slides today. And we're actually going to go ahead and be almost done for today. Let's do... Let's get through list comprehensions today because I almost guaranteed we'll have to review list comprehensions next time. So just really quickly, just to commit it to the record, we've seen how we can access elements in a list, right? We basically do them the exact same way that we access individual characters in a string that we talked about last time. And we have many different ways that we can create a list. One of which is the way that we've been doing already, which is hard coding values. Another is using the replication operator. So in this case here, I've created a list with 100 zeros, but just having a single list with a single zero in it. And then multiplying that times 100, that gives me a list with 100 zeros that I can work with. Which is fun, right? Because there are instances in which we would use this, right? Because I've done examples in the past, and maybe we'll do one next week where I say like, okay, let's turn, and I use basically a big list with 100 zeros as like 100 coins. And I say, okay, well, what if the first time we had 100 coins, they were all on heads, we took every other coin and we turned them to tails. And then we took every third coin and we turned it. If it was heads, it got turned to tails. If it was tails, it got turned to heads. Then every fourth coin, and we turned it. And if it was tails, it became heads. And if it was heads, it became tails. And then after we did that, say, some number of times, like say 7 or 8 or 9 or 10 times, how many coins were on heads and how many coins were on tails? Right? That's an interesting sort of interview problem that you might see in programming that would, really call for a use of something like this, where we start with a big list that's all one number, right? But we could see that in action using I'll go ahead and read these out here and just say, and just talk about the rest of them, right? So we can go back to the replit one last time and do the examples of these. So I'll talk about the replication operator there, which is really useful. The split method is one of my favorites because I can take an input and I can split it based along a particular character. And then splitting it on that character creates a list from a string, which is incredibly useful, especially when you're dealing with inputs. Using the read lines method on a file, we'll talk about read lines when we get to actually working with files. We can put a square bracket around any variable that already exists. That basically turns it into a list. And finally, list comprehensions, which let's talk about list comprehensions, and then we'll do an example of the replication operator, the split method, and list comprehensions all at once. But a list comprehension provides a concise way to both create lists and manipulate lists. So what we basically do is we create an expression that we put inside of brackets that basically becomes a shorthand loop. And so it runs a process, and with that process, it puts it in a new list. And it'll make more sense if I just show you some list comprehension. So that's what we'll do to wrap up today. That's why I say we'll probably have to go back and review list comprehensions at the start of next week as well, just because this is a bit of a challenging concept. So let's go back over to our replit, and let's start out by just making a replication operator here, a replication operator list. So that's easy enough. We'll call it REPLI. Let's use some kind of parameter in this. Let's use parameter X, and that'll be what we use to determine how long our list is. All right, so we'll create some list, my list, and that'll equal 0 times X. And then we'll just print out my list. So now when we call this function, I can call it with an integer-based parameter. And so basically however many zeros I want my list to have, that's what I put in there as my parameter in this instance. So REPLI. Let's go for a big one. Let's say 100. And we get a list of 100 zeros. In the future, when we look at algorithms and complexity, which we do in the last module, we will use enormous lists, right? Lists where 100 items is nothing, right? We're talking thousands, if not 10,000s of items. But we can start out by keeping it small, right? But we can make that number whatever we want, and it's going to give us a list that is that length, and that's basically just it. For a split method, I typically use inputs. So let's create, and we'll call this split underscore method. And we'll take a variable X, and we'll set it equal to input, enter serial number. And then we will do a dot split. And then in the parentheses after dot split, I put a set of quotes, and a dash. And so what that will do is that will take my number and split it along those symbols. So if I have, like for example, let's print x, and let's run this function. Split method. And let's say my serial number was 12-46-98-43-80. So what's going to happen here, right, is when I hit enter, it's going to split up this string along the dashes. So I'd end up with an array or a list that had 1, 2, 3, 4, 5 different elements in it. A 12, a 46, a 98, a 43, and an 80. And that's what we see there. But this does parlay us into a list comprehension. Right? Because one of the things that you'll see, that you'll notice here, is that each of these elements have quotes wrapped around them. And when they have quotes wrapped around them, that means they're a string and they're not an integer or a floating point number. So we can't do math with these. They're strings. Right? If we tried to add two of them together or do some kind of calculation with them, it would not work. So we'd need to do typecasting on them. And we could do typecasting with a loop, like we'd see here or here, right? But we could also use a list comprehension to do this in one line. So let's say we want a new array y, because we said that our list comprehension was a way to make values. And so then in square brackets, we could say int, because what we're wanting to do a typecast here. So int some value, let's say n, right? This is just going to be basically creating an iterable variable for our existing function. So int n for n in x. Or to make it more clear there, we can say num and num. And so that one line of code will iterate through the list that is created by what we've done here in x, go through and take each and every value that's in that list, convert it to an integer, and put it into a new list that we're terming y. Right? So if we print y here, we can run this. We're going to enter our serial number again, 12, 45, 65, 95, 98, 76, just whatever. Right? We can make it as long or as short as we want to. And we hit enter and we see our output there. And we see the first one is just x, right? We left that print x statement in our code here. But the second one is the result of the list comprehension. So the big difference that we can see here is that those items in the list comprehension version, they don't have quotes around each of the values that are in the list, which means that these are just straight up numbers, they're integers. And we can do whatever we want with them. Another thing that we can do with list comprehensions is just basically whatever we want, right? So we can make a list comp here. We can create some list in here, like let's say list X equals a sequence of numbers like 12, 4, 8, 16. And then for list Y, if we wanted to say have a list where we've doubled each of these numbers, we could say like num times 2 for num in list X. And that'll go through list X, take every number out of it, multiply it by 2, and put it into list Y. So then I can print list Y, call that function, and we can see our starting list is 12, 4, 8, 16. Our finishing list over here after we've run it through a list comprehension is 24, 8, 16, 32. Right? Just getting things done quick and easy in a singular line of code. So that gets us well started for lists this week. I imagine we'll have to go back next week and review list comprehensions at least a little bit, right? But that's one of the benefits of that. Next week we'll talk about sorting, we'll talk about adding to a list, we'll talk about removing things from a list, just doing that sort of manipulation to existing lists, right? This week was primarily about creating lists, and next week is about manipulating existing lists. And so that's where we'll go ahead and wrap up for today. If you have any questions, if you're here with me live, you can go ahead and throw those in the chat. If you're watching the recording and you have questions, send me an email or a Teams message and we can get them answered as soon as possible. Lists give us a lot of power in our code. So I'd like for us to spend, a decent amount of time with lists. Can users add to lists is the question. Yes, they can. That'll be something that we talk about next week. We'll talk about using the append function to add to existing lists. So yes. Yes, they can. We can definitely do that. We'll see examples of that next week. But basically all you'd want to do is you'd say list X dot append, say something else, right? That could be the input value or whatever we have. And it just adds it to the existing list. So we appended a 45 there, and it gave us a 90 on our output as we multiplied it by 2. But yeah. Anything else? Any other looming questions out there today? All right. Well, once again, if you're watching the recording and you have a question, please feel free to send me an email or Teams message, or if you think of a question later, please feel free. That's all that we have for today. Thank you for watching. We'll see you next time.